Let's talk about dividing rational expressions. Dividing rational expressions can actually quickly be changed into multiplying rational expressions. You simply rewrite it as multiplying. If you remember with fractions, when you're dividing them, you can keep it, change it, flip it. That means you keep the first fraction, change it to multiplying, and then flip the second fraction. So now you have multiplying rational expressions. So the rest of our steps are actually the same steps that we looked at when we were multiplying rational expressions. We're still going to factor every numerator and denominator. We're still going to cancel the factors they have in common. And then we're going to bring over and write down the simplified rational expression and make sure that we've simplified completely. Keep in mind, I just made an extra note, rational expressions follow the same rules as fractions. So the keep it, change it, flip it works because we're dividing fractions. They're just rational expressions this time. So let's look at some examples. For example 1, I have 7x over 4y cubed divided by 21x cubed over 8y. So the first thing we need to do is rewrite this as multiplying. So we're going to keep the first fraction. So we have 7x over 4y cubed. Keep that one. Change the dividing to multiplying, and then rewrite our second fraction as 8y over 21x cubed. So we keep it, change it, flip it. And then we need to cancel common factors. So since these terms are monomials, we can cancel and simplify the coefficients and the variables. So for instance, 7 and 21 would reduce. 7 goes into 21 3 times. You could put a 1 there because 7 goes into 7 1 time. 8 and 4 would reduce because 4 goes into 4 1 time and 4 goes into 8 2 times. And then it might help, if this gets kind of crowded, to bring over what you have so far and then keep simplifying because I know it can get pretty messy. So we have 2xy right now in our numerator. In the denominator we have 3x cubed y cubed. Usually we like to write the variables in alphabetical order. So then we could see what else can be reduced or simplified. So x with a 1 over 3, you want to leave the x's in the denominator because you have more of them in the denominator. So 3 minus 1 would be 2, and 3 minus 1 on the y would give us 2 also. So our final simplified rational expression would be 2 over 3 x squared y squared. Now let's look at another example. Something a little bit larger. We have 3y minus 12 over 2y plus 4 divided by 6y minus 24 over 4y plus 8. So again, the first step is to keep it. So keep the first fraction as is. Change dividing to multiplying and flip the second fraction or write it as its reciprocal. So we keep it, change it, flip it. Then we need to factor each of our numerators and each of our denominators. So for our first fraction, we could take out the 3 for this numerator, and we'd be left with y plus 4. So always keep in mind, factoring an expression is rewriting it, so it's still equivalent to what you started with. So when I take out 3, if I were to multiply it back together again, it should give me what I started with. So do you notice anything right here? You have to be careful to keep the right signs because that is important. So 3y minus 4 is what would give me back the 3y minus 12 if I distributed it. So down here, well, I can mark that one out because now I've rewritten it as its factors. So let's take out a 2 in the denominator. And we'd be left with y plus 2. So you check and make sure that would give you back what you started with. And then you can mark out the original expression because now you've rewritten it as its equivalent factors. And then on the second numerator, we got 4y plus 8. So we could take out a 4 and we would have y plus 2 left over. So now we can mark that out because I have its factors in its place and they're equivalent to what I started with. And the denominator, I could take out a 6, and I would have y minus 4 left over. Double check that they would be equivalent. Then you can mark this one out, so that way you can really see what's still left over and what you're still working with. Then you want to cancel out common factors. Let's get another color here. We got a lot of green. So we have y minus 4 is diagonal from y minus 4, so they can cancel out. And y plus 2 and y plus 2 would cancel out. Let's see, we could say 3 would go into 6 2 times, and 2 would go into 4 2 times. And then we're left with 2 over 2 is all we have left over. 2 over 2 is just equal to 1. And there are some of these problems that start out looking really complicated, and they might reduce completely just to equal 1 in the end. So don't feel like you did something wrong if you end up with a really simple answer at the end. So let's see. 2 more examples. I have 2x squared minus 6x over x squared plus 18x plus 81 divided by x squared minus 9 over 9x plus 81. So we still need to keep it, change it, flip it again. So let's rewrite 2x squared minus 6x. I'm going to keep the first fraction like it is. X squared plus 18x plus 81. Change it to multiplying and flip the second fraction. And now we need to rewrite each numerator and denominator as its factors. So 2x squared minus 6x could be factored into 2x times x minus 3. Then we could cancel out the original binomial because now we have its equivalent factors. X squared plus 18x plus 81 can be factored into x plus 9, x plus 9, because 9 times 9 would multiply to give me 81, and 9 plus 9 would give me 18, so I can mark out my original trinomial. Over here in my numerator, I could take out 9 and be left with x plus 9, and in the bottom I have a difference of squares, so I would have x plus 3, x minus 3 are my factors. So I always mark out the ones that I've now factored, so I don't look at all this stuff going on and think that I have that much left over, because I only have left the factors that I now need to cancel the ones that are in common. So x minus 3 would cancel out with x minus 3, x plus 9 would cancel out with x plus 9, and then we should probably bring down what we have left and see if we can simplify any further. So in my numerator, I have 2x times 9, which would give me 18x. In my denominator, I have x plus 9 times x plus 3. And we could just double check to make sure we haven't left anything out. And then that is fully simplified. We can't factor 18x any further, and there's nothing out front here that would cancel with 18x. So that would be our final simplified rational expression. So let's look at example 4. We have 4 trinomials we're working with. So there's a little bit of factoring involved there. So just take your time and make sure you factor carefully so that you'll get the right answer. But first thing we need to do is keep it. So x squared minus x minus 2 over 2x squared minus 5x plus 2. Change it to multiplying and flip the second fraction. So 2x squared plus 5x minus 3 is now my numerator, and x squared minus x minus 12 is now my denominator. Then, like I said, take your time, make sure you get the correct factors so you'll get the correct answer. So we have x squared minus x minus 2. We need numbers that will multiply to be negative 2 and add to be negative 1. So 1 times negative 2 would be the right factors. And then you can mark out your original trinomial because now you have its equivalent factors in its place. Now these ones take a little more work because you have a is a number other than 1. So you got to say 2 times 2 would be 4. And what numbers would multiply to be 4 and add to be negative 5. So remember, this time we got to put 2x in each parentheses, multiply to be 4, and add to be negative 5. So that would be negative 4 and negative 1. But then you have an extra 2 that we need to take out. So if I divide this binomial by 2, we would end up with x minus 2 and 2x minus 1. So mark out the ones that you don't need, and we'll come back to that one in just a minute. We've got to finish factoring this expression over here. So we have 2x squared plus 5x minus 3. Again, this one takes a little more work since you've got an a that's bigger than 1. So 2 times negative 3 is negative 6. We need numbers that will multiply to be negative 6 and add up to be 5. So we're going to get 2x in each parentheses, multiply to be negative 6, and add to equal 5. So that would be positive 6 and negative 1. But then we have to divide by 2. So this one divides evenly by 2. So let me move my negative 6. So I would say that if I divided this binomial by 2, I'd have x plus 3 now. 2x minus 1 is still okay. And my denominator is a little easier since a is equal to 1. We could just break it up into factors that will multiply to be negative 12 and add up to be negative 1, which is negative 4 and positive 3. So now, these problems can be a lot to look at. So we look over here, we have x plus 1, x minus 2. We have x minus 2 in the denominator. Things are getting a little messy. So what we can do first, we've rewritten these two trinomials so we could cancel them out. We are not looking at those anymore because we have factored them now. So we have, let's see, x minus 2 would cancel out because there's one in the numerator and the denominator. X plus 3 would cancel out because one is in the numerator and one is in the denominator. And 2x minus 1 cancels out. So, and the negative 6 was just part of my factoring right there. So now I've got x plus 1 left over in the numerator. And in my denominator, I have x minus 4. So remember, when you're dividing rational expressions, you want to actually change them into multiplying rational expressions. So the first step is to turn it into a multiplication problem. From there, you're really doing the same steps you were when you were multiplying. You're factoring everything out. Make sure you factor completely, and then cancel common factors. But notice it is very important that you keep track of your work and that you give yourself plenty of space to work these problems out. They should not be crowded into the corner of a worksheet. So, thank you.